In this video, we will solve a question on hybrid utility function. The question is, suppose a consumer has a utility function, that is, utility is a function of two goods x1 and x2, which is equal to the max of 0.5 x1 comma 0.5 x2 plus the minimum of x1 comma x2. She has some positive income y and faces positive prices p1, p2 for goods 1 and 2 respectively. Further, suppose the price of good 2 is 1, there exists a lowest price P1 bar such that if P is greater than the lowest price, that is P1 bar, then the utility maximizing choice is to buy only good 2. Then the P1 bar is, we need to find out the lowest price for which the consumer will buy only good 2, and options are being given. We need to find out the correct option. Okay, so how do we solve this kind of question? So this is what we call a hybrid kind of utility function. So let us write the utility function that we are being given. So we have utility is equal to max of 0.5 x1 comma 0.5 x2. This is our, plus we have the minimum of x1 comma x2. Okay, now we simplify this utility function first, then we draw the graph to make the things easier. Okay, now in the first term, we need to find out the maximum value, and in the second, the minimum. Let us suppose when x1 is less than, or let us say when x1 is greater than x2 in this utility function. Okay, so what will happen? So our utility will be equal to, so the maximum value here we need to find out. Okay, in the brackets, whatever is the maximum value, we write when x1 is greater. Since we assume x1 is greater than x2, so in the first term we will write only 0.5 x1 plus, in the second term we have the minimum of x1 and x2, and we assume x1 is greater than x2. So since we need to pick out the lowest value, so x2 will be lowest, so our utility function will be x2. Similarly, when x1 is less than x2, what will be our utility? So our utility will be, this time x1 less than x2 means in the first term x2 is greater, so we can write 0.5 x2 plus, in the second term we need to find pick the minimum, so minimum of x1 and x2 is x1 because x1 is less than x2, so we write x1. So our utility function will look like, this, that is, we have our utility will be 0.5 x1 plus x2 when x1 is greater than x2, or, and also we have the utility as 0.5 x2 plus x1 when x1 is less than x2. So let us first try to, let me see if I am within my awqat. So let me try to draw the graph. So we have x1 on the horizontal axis, x2 on the vertical axis. So we have actually two regions, when x1 is greater than x2 and when x1 is less than x2. Okay, so so we draw the graph here. We draw a 45-degree line like this. So this line denotes the region where x1 is equal to x2. Okay, we will try to partition the region. So the region below this blue line will be a region where x1 is greater than x2, and the region above will be the region where x1 is less than x2. Okay, we need to draw the indifference curve first. Okay, So let us pick up the first one. This region we find out. Rather, we draw this indifference curve. For indifference curve, we need to find out the slope of this very region. Okay, so our utility is equal to 0.5 x1 plus x2. Okay, first we need to find out the slope of the indifference curve in this region. Okay, so rather in this region, so take the differential on both sides. So since utility is constant, so the derivative of du will be equal to 0.5 times the derivative of x1 will be dx1 plus derivative of x2 will be dx2. Since du is constant, utility is constant, we write 0 here is equal to 0.5 dx1 plus dx2. Okay, so can I write dx2 is equal to minus 0.5 dx1. So can I write dx2 upon dx1? If I transpose it, gets divided, we get minus 0.5. In the absolute sense, can we write it like this? Our slope, that is dx1 dx2, comes out to be minus 0.5, which is equal to 0.5. Okay, so the slope of the utility function below, rather in this region, it will have a slope of 0.5. And let us try to draw. How do I draw? So let me draw like this. Let us say this is our utility function where we have a slope of 0.5. Actually, I have to touch it to the this x2 axis, but I will not touch it. So we assume its slope is 0.5. Okay, this is the slope of the utility function of this very utility function. Similarly, we need to find out the slope of this. Again, our utility function is this time 0.5 x2, rather yet x1. Okay, plus x1. Take to find out the slope, we take the differential on both sides, 0.5 dx2 plus dx1. So by the way, why did I write dx2 upon dx1? We know that slope is rise our run. Okay, dx2 means the change in this intercept upon dx1 means the change in the the change in the horizontal axis. Okay, so this is our dx2, this is our dx1. Okay, so rise our run. Again here d will be 0 because utility is constant. We have 0.5 dx2 plus dx1. Okay, so we have 0.5 dx2 is equal to minus dx1, or dx2 upon dx1 will be equal to, transpose it here, it becomes 1 divided by 0.5. I hope you are getting it. So it is 1 divided by 1 upon 2. So we will get here 2. That means the absolute slope, that is dx2 upon dx1, will be equal to 2 in the upper region. So our slope in the upper region is, let us draw it by another color. So we will have a utility function like this. Okay, in this region here the slope is 0.5. okay, so let me, here we got slope is equal to 0.5. in this region slope comes out to be 2. Okay, now coming to the question, what does the question tell us? We are being told that we have this kind of utility function. First we format the graph of the given utility function. Now we are being told, suppose she has some positive income y and faces a positive prices p1 p2 for good 1 and 2 respectively. So we will have a budget constraint also. Okay, so what will be our budget constraint? Budget constraint will be, so we have p1 x1 plus p2 x2 should be equal to the income of the consumer. This is our budget constraint. Also we are being told that the price of good 2 is 1. So can we write p1 x1 plus x2 is equal to y? We can write. Okay, we are also told that there exists a lowest price p1 bar such that if the price is greater than p1 bar, then the utility maximizing choice is to buy only good 2. Okay, so we need to find out the lowest possible price for which the consumer is only buying good 2. Okay, so for that we need to find out the slope of the budget line. Okay, what is the slope of budget line? Slope of budget line will be equal to, that is the price of good 1 upon price of good 2. The price of good 2 is being given us, rather price of good 2 is being given 1. That means slope of budget line will be equal to, in absolute terms, it will be equal to p1 divided by 1, which is equal to p1. Okay, now we need to find out what will be the lowest possible price for which the consumer will choose only good 2. Okay, so at that point what should happen? If consumer only wants to buy good 2, then the slope of this indifference curve, okay, rather our budget line will be of 2 types here. If the consumer wants to buy only good 2, then what will be the slope of budget line? Slope of budget line should be like this. This should be our budget line. Okay, now what is the slope of budget line? Slope of budget line is equal to p1. Okay, for consumer to choose only good x2, in this case the slope of budget line should be greater than the slope of this indifference curve, which is in this region. Okay, in the above region. Let me explain it here. Since we are, why I am taking the mod here. So what I want to say to you people is that we are being told we need to find out the lowest price for which the consumer is only choosing good 2. So consumer will choose good 2 only, and we know that for utility maximizing choice, the budget line and the indifference curve should touch or should be tangent. Here it cannot tangent. So since we have to find out the price where the consumer is choosing only good 2, then our budget line should intersect this indifference curve. That means the slope of this budget line should be greater than the slope of the budget indifference curve. What is the slope of the indifference curve here? It is 2. Okay, another scenario could be, that means so slope of budget line is p2, slope of indifference curve in the upper region is in the upper region is 2. Okay, so what will happen then? That means slope of budget line is p1, slope of the indifference curve is 2. Since slope of the budget line should be greater than the indifference curve, that means p1 should be greater or equal to 2, since we need to find out the lowest possible price or the price for which the consumer is choosing only good 2. It will happen only when the price of good 1 is greater or equal to 2. In this case, that means P1 should be greater than 2, for which the consumer will choose only good X2. Another case can be when price is Subhanallah Jalla Shanu is less than 0.5. In this case, our indifference curve will look like this. In this case, the consumer will choose only good 1. Okay, so I hope I make myself clear in this video. So the correct option should be 2. Okay, I could have explained it further because azan is going. I hope I make myself clear. Thank you.